The shift to remote and hybrid work over the past 2 years has accelerated application development on cloud infrastructure. However, securing these new assets has lagged behind. Qualys Cloud View, the next generation cloud security posture management, delivers an end-to-end multi-cloud security and compliance solution encompassing the entire application lifecycle from build to runtime. Cloud View enables enterprises to assess their cloud security and compliance posture, identify risks and gaps, auto-remediate issues, proactively enforce best practices, and prove compliance in audits rapidly and efficiently. Identify your most vulnerable cloud assets by visiting securityweekly.com/Qualys. Securing the modern enterprise requires insights into massive amounts of data. NVIDIA Morpheus harnesses the power of AI and GPU computing to help protect networks in a way never before possible, enabling 100% data visibility to provide cybersecurity analysts the tools to identify, capture, and act on threats and anomalies. Sign up for a free 1-hour NVIDIA Deep Learning Institute course. To learn more, visit securityweekly.com/NVIDIA. UFOs are everywhere. That's right, UFOs, unidentified file objects, are hiding in files in your cloud apps and storage. UFOs can contain malware that exfiltrates data or deploys ransomware. 70% of UFOs in files can't be detected or prevented by traditional scanning solutions like antivirus and sandboxing. That's where Vatiro comes in. Vatiro prevents UFOs before they hitch a ride in on files in the cloud, without detection and without slowing down business. Learn more at securityweekly.com/Vatiro. Welcome back to Application Security Weekly. We just talked with Martha Bennett and Sandy Carielli from Forrester Research about Web3, decentralization, smart contracts, and where the security is in all this. I'm your host, Mike Shima. I'm here with John Kinsella and Akira Brand, and it's just about time for the news. But first, don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. And I think that is all I've got for our announcements this week. It's pretty short. We just had a spirited discussion with our Ouija boards and summonings with Martha and Sandy, which was pretty fun. And we're talking about vulnerabilities in Web3, decentralized areas. And John and Akira, we've got some fun vulnerabilities outside of Web3 to talk about. And one thing's real quick, though. Akira, you're a new voice here. Why don't you introduce yourself a little bit real quick and then introduce the article that you want us to talk about?
Yeah, sure. So hi, everybody. My name is Akira. I'm really glad to be here. Thank you for having me. I work in developer relations at a cybersecurity company called Bright Security. A lot of my job involves educating developers on secure coding practices. I'm currently working on some really amazing partnerships with other companies like Sneak and Postman to be able to sort of bring our message of AppSec to a wider range of audience. And on that note, I'm also relatively new to AppSec myself, so I'm very glad to be able to be on this podcast because I'm learning so much. This is my first episode, and I've already learned, oh gosh, probably more in one episode prep work than I did in maybe 2 weeks of university, so that's great. So yeah, I'm really glad to be here. And on that note, I want to share this wild article I found. This just blew my mind. It is called Siri Spy iOS Bug Allowed Apps to Eavesdrop on Your Conversations with Siri. So there's kind of this funny, I'll call it an urban legend going around that Facebook and Amazon like totally listen to everything you're saying on your phone so they can sell you more targeted ads. And of course that has been completely debunked at this point. However, with this particular vulnerability, this actually happened. This was discovered by a developer named Guillermo Rambo. And let me just give you a quick timeline kind of what went down. So Guillermo Rambo works on a project called AirBuddy. And while he was working on this project, he discovered that any app with Bluetooth could record your conversations with Siri and audio from the iOS keyboard dictation feature when using AirPods or Beats headsets. Side note, I used to have Beats headsets. I lost them, and I think I'm a little bit glad at this point. So Guillermo was working on a tool he created for his work on AirBuddy called Bluetill, which allows for interaction with Bluetooth devices on macOS. And then while he was adding a new feature to this tool, he noticed his AirPods included a service with a specific UUID and with characteristics that supported notifications. So he said, okay, well, let me run my new tool here against these AirPods. And he noticed then, though, that no events came through. So what's that about? He actually then later discovered that the UUID was a DOAP service, which is a service for Siri and dictation support. So Guillermo decided to test it again, and while he was waiting for the events to come through from the AirPods, he invoked Siri, and then he noticed that tons of hex bytes started to stream to his terminal. And he thought two things. He thought, oh, this is really cool. I bet this is audio data. And then he, by his own admission, said, oh, no, this is not really cool. This is audio data. He then decided to work on decoding it, and maybe it was encrypted, hopefully, and it totally wasn't. It was not encrypted, and it was in fact audio data. He then went to write a small application that tested this on all kinds of different Mac devices, and it turns out that it was mainly on Mac OS that this was an issue. And then at the end of the day, this was essentially a ability to completely bypass the TCC protocol in Mac OS. And essentially, it's kind of interesting because to me, and again, I'm still kind of parsing through some of the technicality of this, but it seemed like a relatively simple fix where the system processes that are responsible for handling the DOAP protocol were just interfacing with the daemon incorrectly. So then they fixed the interface with the daemon, and now the problem has been fixed in, I think, the 16.1 release that came out on October 24th. So now you can't have apps just randomly listen to anything you want to talk about while your phone is next to you.
No, if anyone's going to listen to random things that were being talked about, they should be listening to ASW, of course. But I think of course. But Akira, what was interesting about this article is that it's a good example of something John and I have been highlighting, is that become an expert in a technical area. Do a deep dive. In this case, the researcher was doing that deep dive into the Bluetooth protocols, like you were pointing out, and just saying, not doing this for security research, but by becoming that expert, having some tooling, just saying, that looks interesting. And as you described it, I've identified what was also a $7,000 bounty, I think, from Apple.
Yes.
So also some pretty good work. And the other aspect here too is that TCC is that concept of, here's how code signing and permissions should work together, because there's at least provenance of this app has this, because it's signed, this is its identity, to use a callback from our segment with Martha and Sandy. This identity should have these permissions. But as you highlighted and noted, and what the researcher found, there was a little bit of a disconnect in those permissions, and then things went sideways, privacy-wise. Other things that can go sideways are ... slashes. So Akira, this is you be patient, because you may discover that one of my favorite vulnerabilities ever is just the path traversal. Because speaking of going back to the 90s, maybe even the 80s, as we were talking the ancient history of the web, it's a vulnerability that just keeps on giving. And John, you were kind enough to also notice Juniper OS, I think, had these flaws, but it was a list of flaws in a bunch of PHP code, which just reads like almost 1 through 10 of the OWASP top 10.
Yeah, we're doing pretty good on the scary stories here today. So yeah, this one, they really did have it. Yeah, it's almost 10. So it's 6 vulnerabilities that were found in one of the Juniper Networks products. So this is to talk about the product for a tiny second. It was SSL VPN. I actually got to use these, I don't know, probably a decade ago. And they were actually super cool, because usually VPNs are these complex things and you got to set up the clients. And we didn't actually mention there's also a vulnerability in the Cisco VPN client this week on Windows. But anyways, another scary story. But the beautiful thing about the Juniper SSL VPN is your users go to a website, they log in and authenticate, and a SSL tunnel is created between those two systems. So it allows people to get to your corporate data without having to, deal with these stupid clients. So I really love them. But anyways, there's a variety of mishmash for us to talk about. So as you mentioned, there's a path traversal. issue in here. We've got some pre-authenticated reflected cross-site scripting, pre-authenticated path to serialization to remote code execution, XPath injection. I can't speak. 2 forms of XPath injection. So they found, a whole bunch of different things in here. But I think, Mike, part of why I put it in was just it's PHP, and there's nothing wrong with PHP by itself. But at the same time, in 2022, do I want my security products to be written in a scripting language? And I think this is something I've probably had, obviously sort of the mental pause that's happening now with it over the years about PHP or Python, or it's first, and it could just be an unrealistic expectation on my part, or a standard of I expect, or I think those are going to be more secure just if they're compiled. That probably, as I say, it isn't really an accurate statement. But I don't know, either of you guys, if that sort of sounds real to you, or if that's just me.
I would say that I would agree with you, but also I think we all need to meet developers where they're at, right? So we can say no, we need this to be a compiled language, but if the devs aren't going to write that, then they're not going to write that, right? So I think it's a little column A, little column B.
Yeah,
And
I think
go ahead.
Go ahead, John.
Oh, as we're even thinking about now, I didn't really mean to say that anything written in JavaScript or TypeScript is insecure because it's a scripting language. And it's funny. So
Sure.
However my brain went around maybe first gen scripting or second gen, or I don't know what gen you want to call Python nowadays. But anyways, yeah, keep going, Mike.
Yeah, I was going to say, if we forgot about Python, we'll just have to call it Gen X because that's what everybody forgets. But I was going to make the point about PHP. Not so much. My question here was, what is the age of the code, of this PHP code? Meaning, was this 10-year-old code that has just been maintained because of PHP, or was it modern PHP? And the reason I make that distinction is that, John, I do think you were going to the angle of, do developers have time? And to Akira's point, meet them where they are. We don't need to reteach all of these PHP developers into a compiled language so they can reintroduce the basic vulnerabilities in their Web3 smart contracts. We can do with, PHP, modern PHP has, you can decorate it with type safety. You can actually do a lot of modern, good design patterns. And that's where I'm just curious, is this a modern code base or more of a legacy code base? And that's the bigger dimension that's impacting this. And
I'm willing to put money on, I'm betting that, the developers who wrote this have been learning new tools and techniques and languages, and they've moved on somewhere else, and they're not actually developing this anymore. So
very good point.
Yeah. And I mean, that's again a bigger question. Still leave the scripting thing out of it, but how do you support, I mean, this is you're not going to keep developing with my manager hat on, I'm not going to keep developing the web interface for a VPN product. How do you keep maintenance on that over years and years as that product is being successfully used and generating successful revenue for the company? How do you make sure that still gets some amount of love occasionally?
Well, speaking of projects that need some love, especially since they've been around for a long time, tonight at midnight, a new daemon appears. Actually, I don't know if it's at midnight, but at least on Tuesday, OpenSSL is going to lift the embargo on a critical vulnerability. The last time we had a really critical vulnerability in OpenSSL, I think it was 2016, and it was 2014 that was Heartbleed. So one of the things you could look at, here is a success story. If it's taken 6 or 8 years to get another vulnerability, we don't have a name for this one yet, so I don't know, John or Akira, you can start thinking about how this might become a named vulnerability while I introduce a little bit more of it. But we don't really have too many details around this, but it affects OpenSSL 3.0. And an angle I wanted to talk about here is that, honestly, probably everyone is still on version 1.1.1. And very few people have migrated onto version 3. Version 3 only came out September 21, so it's been out less than a year. You have OpenSSL 1.1.1 that just works, John, to a little bit to your point. It's not the web front end for a VPN product, but it is in that VPN stack, I could pretty much guarantee. But another angle, just as I say that to say, well, maybe the sky won't be falling because it's not going to be pervasive. The other part of 1.1.1, there's only 1 year, less than a year actually, of support left for it. So you should be migrating to 3.0 anyway. Or, of course, you could go on to Boring SSL or one of the other TLS stacks that actually don't rely on OpenSSL as it is. So maybe I've got a couple more thoughts on this. But John, have you had either a chance to think about your thoughts or whatever this named vulnerability should become?
No, man. I keep trying to work on it, and I'm looking at the calendar. There's nothing good coming up. I mean, it's Halloween today. It's I could do Scary Bites, but that's too easy. Pumpkin SSL, no. Return of the Pumpkin. I don't know. Kira, you got anything?
The twin pumpkins is, I don't know, I figured maybe we're on a Lord of the Rings kick, the Return of the Pumpkin, Fellowship of the Pumpkin, I don't know.
Well,
my only thought is, that Mean Girls meme where there's all these mean girls in a Corvette and they're like, get in loser, and then it could be get in loser, we're going to migrate to 3.0.0 SSL.
Stop trying to make 3.0 happen. It's not going to happen.
But back to your first point, Mike, this will be released between 1 and 5 p.m. UTC. That is when I will be...
The witching hour.
Oh, not quite asleep. I guess it's around this time tomorrow, huh? Ooh, we should have recorded it a day later. Let's see. You said something else. The other question I have is... I'm curious to see if the other SSL products will be affected by this. So they're forks of OpenSSL, and this is sounds like it's newly introduced. We'll see tomorrow. So maybe if they forked before and they didn't follow everything, they might be safe. It's going to be an interesting week for people, and I don't mean that in the friendly way, unfortunately.
No, I think my prediction is going to be this is not a hard prediction. I'll have to predicate it to be fair, but it's going to be in the ASN.1 parsing because that just historically ASN is horribly insecure. It's tough. It is way too complex for what it needs to be. And the reason I say that too is that we haven't heard the other TLS stacks like Amazon has their own, Cloudflare, Google, others come out and saying that they're also vulnerable. So that's why I say I'm going to guess it's something kind of particular to the parsing within OpenSSL and a lot of perhaps the cleanup they were attempting to do. But we'll see what happens and how my augury works, and to use a really fancy word. But speaking of fancy words that are really long, SQLite was dealing with a really long string. And here is Trail of Bits doing some fun work, which, speaking of our prior segment on Web3, I also posted in the show notes a link to Trail of Bits research on centralization or not within the Web3 ecosystem. So do check out that. We covered that before, John. Here is a flaw they found in SQLite, which, as the planets align, they found it through PHP. They actually were doing some testing on PHP. They said, here's a funny bug, but the bug is not in PHP. So, much like the hand reaches out through the graveyard at the end of your favorite horror movie or so, it's SQLite that is coming to attack because the flaw was actually in the well-tested SQLite. And the reason I throw well-tested in there is that if you look at the show notes, I linked to their testing philosophy, and SQLite has, I think, 100% branch coverage testing. They put a lot of effort into this, and still a flaw snuck through. And the big reveal, so those of you who don't like spoilers, cover your ears for a moment. The big reveal is that Trail of Bits essentially found this through an integer overflows dealing with 2 gigabyte, 3 gigabyte size strings. So it does have some pretty big prerequisites for being able to exploit this. But SQLite's testing harness said, we're just going to deal with a memory limit of 1 gigabyte. And so their testing harness by design prevented this type of edge case testing, which can make sense. At the time, SQLite is old, 10, 20, I forget actually, I got to look this up now. But at the time it was created, 1 gigabyte was probably just fine for a string. And honestly, it feels more than fine for a string. but that's where we come today, that you got a fun and a rare exploitable flaw within SQLite. So Akira, I don't know if this is something that, if SQLite is something you've encountered, or just this type of 100% test coverage. Does that sound scary to try to implement, or does that sound impressive that you've ever, have you ever seen that before?
When I was in school, I sure did. But now that I've been in the industry for 30 years.
Thank you for the honesty. I love it.
Yeah, for sure. Yeah, no, I mean, I have not seen 100% test coverage. I think there's like an industry average, I think, is like, if it's a good day, you get something like 70% or something along those lines. John, I'm sure you can.
70 is great. Yeah.
Yeah, that's on a good day. That's like what you would get, right? But yeah, that would kind of be my 2 cents on that. But John, maybe you can back me up on this 70% thing.
Well, at first I had to say I'd start with the SQLite is in the house. And it's the top question on this is, where is this thing used? What's SQLite? What is this thing? This is a database which was designed in 2000, Mike, for
thank you,
lightweight devices, your Raspberries, your Arduinos, your embedded things and things like. It's a light database. It doesn't have all the fancy bits. Mac OS uses it fairly heavily for configuration of various different things. A lot of applications use it. It's in a ton of IoT things. So pause for a moment and think about how many databases are running right now in your house. Okay. Back along what Akira was saying. So just thinking about, let's focus on the testing aspect of this is really interesting to me. 100% test coverage, I think almost anybody, it's something you see in academic and in that real world. And it's I would say in an application, I'm stoked if me or my teams hit 50, 60, 70%. I probably had 70 or 80% a year ago. I don't have it now. And that's the scariest part, which I wanted to bring up, is like, it's not that they have 100% test coverage. That's impressive. If they can keep 100% test coverage, that means every time you're developing new things or actually implementing something, you still have to take time to do that. And that's the scary part to me. That's not that it's slowing it down, but it's adding more, both the pressure to do that and figure out how do you test this. And like, I know once the culture's there, it becomes easier, but that's still a heavy lift mentally. And then the other interesting aspect of this to me is sort of, okay, so this might cause teeth gnashing in the audience. I'm a fan of test-driven development and testing and all these type of things, so I'm getting that out of the way. And I love open source. Is there an avenue for an attacker to look at the test suite for an open source application and use that as part of their security research to figure out more easily where weaknesses are in an application? So in other words, can they find something like this where, okay, well, they had an artificial limitation, or you can find a part that's not tested and do some testing on that, or you can take that test harnesses and use those in fuzzers. These are all things I don't want people to be scared. That's why I started with, don't teeth gnash at me. But at the same time, that's sort of I could see that causing concern for some people. Remember back mostly in the 90s and 2000s, I know we're still getting them, but back then you'd have like management teams and business saying, you can't trust open source. You can't use open source software because it's insecure, because it's in public and everyone sees the code. People are still saying that stupid thing. I think about it, but is this sort of feeding that in a way? Maybe don't open source your test suite. I hope not, but it crosses my mind.
I hope not. And that's a great point, because it definitely adds more than just, grep for all the to-dos or grep for the fix-me's from a security perspective. Look at just what are the issues that are open. This isn't working. What are the test cases? And I want to say that OpenSSF has been investing in, we'll give you a bounty for improving test coverage, as well as a bounty for harnessing that test coverage up to a fuzzer, because the test coverage is intended to, especially functional testing, is intended to exercise the application, which is what you want to do with a fuzzer, so that you can identify more bugs as well as security bugs. So I do think you're onto something there. So hopefully, John, everything is not super scary and stressing you out. Let's turn our attention to something perhaps more calming that I'm going to pronounce as clams, because I just misread that as the article title. So you're going to have to introduce this one, please. Once you can stop
shellfish in our cloud security. So this is an article from our friends over at the news stack that were they watched a keynote from Maddie Stratton at DevOps Days. And I put this in here. It's a good coverage of what happened and what's going on. But at the same time, it's interesting to me, sort of tying back to our previous segment, talking about Web3 and security and the same mistakes all over again. This article is talking about using the DevOps concept of columns, which I'll explain in a second, and applying that to your cloud, your use of cloud, and how you go about doing that. And so columns, to sort of get that out of the way, is talking about culture, automation, the leanness of your application and your development style, measurement. So in other words, your metrics and things like that, the Google Dora metrics, and then sharing. So in other words, helping the rest of the community in the world. So that I think that describes DevOps to most of us. We would agree with that. And DevSecOps, you can fit in there as well. And his talk is about how do you actually apply that to, as I said, something in the cloud. So, cloud engineering, infrastructure as code, all those type of things, repeatability, usability, the culture of how you use the cloud. The question, the big thing for me actually outside of the article is, why do we have to reteach this? Why do we have to? Is this something? And I'm not saying that his talk was dumb or not used or not very well accepted and consumed, but why did we need to be taught that again? So it's sort of like going back to the Web3 segment we just did, Web3 security. They were pushing us to say, we knew that the logic issues, the application security issues, the phishing issues, like there's nothing really new going on over there, right? It's decentralization theater. I love the phrase. But so bringing that back to cloud, and leave aside the fact that we've been talking about cloud for security for years, did we really need to go back through and were people struggling with this? Had they not figured this out? I guess that's my question to both of you guys is was there or why is there a vacuum in how to do something like this in the cloud? Was this not obvious to people, or was it not already, I don't want to say baked in, but baked in was not inherent? So I don't know, that was my sort of about this.
I mean, this is pure conjecture,
Please.
right? But I wonder if it was never taught properly in the first place, and that's why we have to redo it. Instead of, does that make sense?
Yeah,
maybe
going.
we have to kind of rephrase it over and over again because other people just aren't they're just maybe this is give them the benefit of the doubt. Maybe it's the first time they're hearing it at all.
Yeah.
So that could be part of it.
So you're walking into a theme that Mike and I have had for 6 or 8 weeks now, probably longer, actually way longer. Who am I kidding? Of education of security, and you
Right.
mentioned in your intro of in your prep for this episode, you felt, I'm going to say felt it because I don't think you did, but you felt like you learned more about AppSec than you did in school.
Yeah. Oh yeah.
So, and we've covered a few articles on this recently. Forrester had a great piece recently on this. Is there, and this is my ongoing question as I ask those guys at the end of the episode, is how do we improve upon this? How do we make this better? How can we educate people so that if that's what it is, that it's not as repetitive?
Yeah, and I think for me, I look at this, and I think what stands out in the columns is the A and the M. So automation, that's super easy. That's what lots of people glom onto because we want to automate containers, Kubernetes. We want to automate in the cloud and here's our step functions that are connected to Lambdas, connected to this other thing. And we want to measure it, of course. Those are very technical approaches, but they don't touch on those other aspects that you're highlighting from this presentation and from other, the way that teams succeed, which is what are the team dynamics? What are the collaboration? How do you talk and reason through, this is what we need to, these are the trade-offs that we need to discuss, whether or not we maintain our test coverage at this 70%, as we're introducing new features, or we're going to let it slide. Here is a architecture trade-off. How do we talk through this? What's the cross-functional discussion between product managers and business cases and engineers? And I think these are harder to teach just within a pure comp sci environment, perhaps. So that will be my conjecture about why some of these aspects feel like we're still reinventing them, perhaps, John. I'm going to jump over because there's a lot of other things that we want to get to. Sure. Real quick, speaking of reinvent or new things, Docker and WebAssembly. This caught your eye.
It did. I'm looking forward to playing with this one, I have to say. So we've been talking about WASM, for a while, web application security, WebAssembly. For a while, obviously not long enough because I'm still getting it wrong, even though it's literally right in front of me. But so Docker's been working on this. I think the first peeps came out this summer, I want to say July, but they've now released on Docker for desktop the ability to deploy WebAssembly without needing a container. And that's the interesting part here. And there's another, I was trying to find it before the show, I can't find it. I know there's another open source project out there which allows you to deploy code in Kubernetes without containers too. So this isn't the sole kid at the dance, so to speak. But it is an interesting kid. So what they're doing is they've partnered with, or they're using, WASM Edge, I think it's called, is a runtime for WASM. And basically they'll schedule, they'll orchestrate where it runs in your cluster of Dockers. I'm going to use that phrase and not mention the S word swarm. Oh, well, I did it. But they're doing that and probably on Kubernetes as well. And the idea is, do you need the overhead of a container, right? If you're, we've gone from the days of needing the virtual machine to be spun up and built by hand or automated, as we were just talking about in the cloud, move to a container, then you move to lightweight containers where you don't have all the extra junk you don't need in them. And then you'd go to I'm losing my phrases up, bare bone container. But anyways, a smaller container still, but that's still, you're using a container. There's some amount of crunchy which has to be done there for you to run that. On top of your compiling your application and getting it into the language you want or into the bytecode you want. So now we're saying, hey, let's pull that step out completely and just, give us that bytecode. We're going to go and throw it into the orchestrator and go and run it in the cloud. Or in your cluster, wherever it is. So I think that's to me is really interesting. And that's what they're doing. So that's what we have it here. It's not purely a security thing. We could say WASM might have security implications in a good way, but it's from the DevOps side of things, which we do talk about occasionally. I think this is going to be sort of neat to watch and follow.
Absolutely be neat to watch. And I like watching it from the perspective of the sandboxing and isolation properties of the WebAssembly, as well as the security introspection that could be applied to it. So hopefully we will get out of that, it will tamp down that class of memory safety issues within WebAssembly, which admittedly JavaScript doesn't have because of the language, but the language execution does, because the underlying engine is still that C++, essentially, which is how I'm setting up for the blogs, plural, from Apple. They have inaugurated their security research blog with one about bug bounties that'll skip over real quick and just say, they've joined the ranks of how much money they've spent on finding bugs. I would still love to see how much money these companies are spending on fixing those bugs. Let us know. But the other article is about memory safety issues. Now, Akira, even though that you perhaps have been a recent graduate of university, I'm not going to grill you on the details of memory safety because that sounds slightly unfair.
I'm actually still in the university, so grill me even less.
Yeah, okay. So, but I will suggest then is check out the article, and anyone that has a great intro to memory safety issues, as well as a good taxonomy of them in the sense of here's temporal safety, here's spatial safety. In other words, here is a buffer overflow versus a use after free. Why are those different types of attacks? And why do those different types of attacks need different types of countermeasures? So it's a great article that does dive into a lot of good technical details about how Apple does this. So I wanted to highlight the taxonomy, read through that. It's a great way to also understand how they're reasoning. At the end, they say this is some of the weaknesses. We're not fully preventing the entire class of issues, but this is how we're getting there. And John, you might appreciate this. It's a long-term effort. They talk about how they slowly introduced in iOS 14 and then 15 and now iOS 16 a lot of these memory hardening tools. So it is definitely the marathon approach to security rather than just we're going to throw something in and forget about it.
Yeah, it's funny. It's a really interesting point. It's to me. It's frequently even when we talk about something on the show here, we're talking about how do we fix something, how do we get something done. I think education is a good example of a longer term thing. But how you deal with that in your organization or even personal projects. I've probably said here before, I've got that consultant background where I usually think of things in phase 1, 2, 3, sort of break things down into groups like that. But this is, we're talking year 1, 2, 3, OS release 1, 2, 3, right? These are big, major sort of things. So it's pretty neat to be able to see someone planning out like that and sort of watch sort of the synthesis and how those things change over time. But it requires a lot of foresight. So it's sort of neat to see them doing that.
Yeah, I think so I was trying to run through that so we get to one final article that this is fun and different. And I'm just going to set up, we like fun and different because it's entertaining, at least to us. And Kira, one of the other things that we also like to highlight is how can we apply concepts of threat modelings or application security principles to things that just aren't a front-end web application, something that's written in PHP on top of a VPN. So, John, do you want to introduce this article? Because I think you saw this as well.
Yeah, we did. I'm speaking myself in the royal again. Here we go. We both saw this. So, article in BBC talking about how a magician mathematician, easy for me to say, revealed a casino loophole. So this is it's one of those stories, and we've got a few of them this week, I think, or at least one other of like how the rest of the world and how things which are going on out there, how it applies to security or AppSec. And this fine gentleman had an interest in it's sort of the history. The story talks about the history of where he came from and how he got into this, but like, he got interested in card tricks and figuring, how does someone do that? And sort of there was a magic shop in town, I believe. And sort of going through, he figured out some of the weaknesses in different styles of card shuffling. This is something which, you see the magicians on TV or in even like a dealer in Vegas or wherever you are. If they are not using machine, we'll start with not using machine to shuffle cards. And he figured out and got good enough that he is able to do in front of you what looks like a real shuffle. And he figured out that if you do it, I think it's 7 times, he could then predict where a card could be and then show some of the card that they picked out of a deck. So pretty neat things he was doing, but it are actually based in math. So he went forward with that idea, not just doing the perfect shuffle by hand, but realized that there's also problems in these machines. So the article sort of talks through this. And in the end, he got paid by one of the casinos to come down and actually was it? I can't remember if it was a casino or the shuffling. I think it was the shuffling machine, right? So what they had figured out was it used to be transparent, so people could actually watch the shuffle happening. And they thought they had a better way of doing that, and he came down and worked with them, and they had to throw away one of their shuffling machines and come up with a new design. But it's interesting to see how something which sounds completely unrelated actually has, we were talking again about casinos briefly in the beginning segment. So we're sort of bringing it back to where we started.
We are, and there's some neat, obviously we talk about randomness, and I think at least hopefully a lot of people's thoughts go to cryptography because cryptographically secure randomness is quite important to such things. And this article is a great example of an oracle or predictability, because as John was describing, this casino shuffler basically had a bias. And so the researcher, the mathematician, could see, it's more likely we're at this part of the deck. So if you're card counting in general against a random shuffle, the card counting can become even better because we're into the high number cards or low number cards. So and that's just a bias in the randomness, which I'm trying to stretch a metaphor a little bit. Think of that from encrypted data that here's a bias towards revealing a few bits of a key, of a private key, for example, or a few bits of an encrypted message. These become very important to cryptography researchers and people who are doing things like working on OpenSSL as well. So we've managed to tie together, once again, several of our articles. So I feel like my work is done here. My brain might be a bit exhausted from doing all that together. John, any final words that you wanted to highlight as we wrap up for this Halloween?
On this one, I think actually one thing that caught me in this article as I read it is they actually mentioned Markov chains, which is just, once again, that was sort of a bit of the tie between the two, right? The last thing you'd expect when you're reading through this article on the BBC about a mathematician or magician. But yeah, so it's a good read. It's of decent length, so I hope people go and check that out. And then I think I'll close by saying welcome, Akira. Glad to have you here. Looking forward to having your input in all these articles, and welcome.
Thank you. Yeah, I appreciate it. I learned a lot from just today, and it's been really good kind of chatting back and forth. And I don't know that I have any final thoughts aside from, gosh, this Siri thing just kind of freaked me out. I don't know. I liked it. But it was very cool. I really enjoyed, at least in my article that I brought today, that the problem seemed really, really large, but the solution was actually quite small, which I think is just kind of like a good life lesson in general. But yeah, it was not an overwhelming problem to fix, even though it seemed like an overwhelming thing initially. So that's pretty sweet.
That's awesome. Well, yeah, and definitely listeners, please do share some more articles that you think might catch Akira's attention from that perspective, because we would love to hear more. And I want to say, of course, thank you, Akira, for joining us. Thank you, John. Thank you of all of our listeners. Please do subscribe, hit that like button, check out the show notes, and speaking of Halloween, check out the music and movies of John Carpenter. Not only has he created several iconic movies, but he's a major influence in synthwave. And with that, we'll see you next week on Application Security Weekly.